Bienvenue à Nick Does Maths. Je suis Nick, voici Maths. Welcome everyone, welcome back minions, math magicians big and small. We are going to do some more funky maths today. What do we have? We're talking words, but not proper words, maths words. So basically, a lot of times you'll get these questions in sort of funky maths things, especially like in the MAT uni entrance exams, where we define a word just as a string of letters, a string of characters. Now in our case here, we're going to define oxwords. And oxwords is just made of strings of A's and B's. Wicked. Or a sequence of A's and B's. Now, here are my 3 rules for creating oxwords. First of all, just the empty sequence is an oxword. You could have no A's, no B's, just is an oxword. Awesome. Now, if W is an oxword, okay, if we have an oxword, we can create a new oxword by sandwiching it between A and B. Okay, all right, we'll see how this works in a second. If I've got 2 different oxwords, just 2 oxwords, I suppose, U and V, stick them together, you get an oxword. All right, and we'll see what we mean by that in a second. Now, number 1, do all oxwords have an even length? Well, let's just build a few, because number B, we're going to want to list all of them length 6. So let's just try building them. So our first oxword is just nothing, nothing at all. Okay, but let's use our rules. I've got 1 oxword, so I can't sandwich 2 of them together, but I can take my empty one and sandwich it between A and B. So A, nothing, B. That is an oxword. Now we're cooking. Now what can I do to create new oxwords? I could take my oxword and sandwich it between A and B. So what we might do actually here is let's do this in red. All right, so my oxword is there. So what I can do is I can go A, B, and then B. That is a new oxword, A, B, B. Well, the other thing I could do is if I take 2 oxwords and sandwich them next to each other, I get a new oxword. So I could have AB, and just so we can really see where this has come from, AB, AB, AB. Now this might already help us. I'm going to a little bit of space here so I can do this length 6 ones. These are length 2, these are length 4. Now, let's go. So the point is if, let's go L. If the length of W is even, right, or whatever it is N, then the length of the word AWB is N plus 2. So if N is even, then N plus 2 is even. Okay? So we've already got that. And in the same way, right, length of U plus the length of V is the length of UV. All right, if I just smash the 2 words next to each other, that overall length will be the length of both of them. But if this is even, and that one's even, then this one's even. And because the length of just nothing is 0, which is even, this is basically induction. This is proof by induction, right? Because the length of the empty word, you can even start with AB, right? Our smallest actual real word is AB. But because the length of that is even, whatever you do, if you sandwich it between AB, well, you're just adding 2 to the length, so that will be even. If you smash 2 words next to each other, you will have an even length plus an even length, so overall you end up with an even length. Simples. Right, let's carry this on, because we want to keep finding we want the length 6, so length 2, length 4. So how could we go for length 6? We could take this one and smash it, let's go here, between an A and a B. So we could get A, B, B, B. So I've taken this one and I've smashed it between A and B. I can take this one and smash it between A and B. So A, B, B. Then what could I do? Well, I want to create length 6, so I could take a length 4 word and a length 2 word and smash them next to each other. So that will be AB, B, B, and do it the other way round. A, B, B, A, B. All right? This word, then this one, then that one. Now, quick check. Do I have any duplication here yet? AAB, AAB, but these are different because that's AABA, AABB, so we're okay. And we can do the same thing here. I can go that word and that one. AB, AB, AB. Or I could go that one and that one, but then I've gone back on myself. It's the same word. So how many are there? There are 5. There are 5. Now, if W is an Oxword, does it contain the same, sorry, that should be A, that should be B, C. If W is an Oxword, does it contain the same number of A and Bs? We are back to this argument, right? Let's take our smallest one. Our smallest one, AB, here has the same number of A and Bs, one of each. How do I create a new word from it? Well, I'm either adding an A and a B. Well, okay, well, I've added one A and one B, so what do you want from me? Or I smash it next to another word. Now, by induction, if we say all the smaller words have the same number of A's and B's, if I put 2 of them together, that will also have the same number of A's and B's. So we're back to this sort of induction idea here, is because AB has the same number of A's and B's, any other Oxword will have the same number of A's and B's, because either I'm just adding an A, adding a B, so we're still good, or I've put it next to another word that has the same number of A's and B's, and so on and so forth. The dominoes fall. Right. Now, Cn is the number. Now, we're going to assume, we are told we can assume that any Oxword can be written in this form. A, W, B, W dash. Okay. Now, Cn is the number of words length 2n, because they're always even, right? So we're going to express it that way. So C1 is the number of words length 2. C2 is the number of words length 4. C3 is the number of words length 6. C3, number of words length 6, and so on and so forth. Can we get an expression for Cn plus 1? So I want a word that is length 2n plus 2, all right, length 2n plus 2. Well, I've already got 2 letters here, right, Cn plus 1. So Cn plus 1 is in this form, AW, BW dash, right? But that means, because I've got the 2 letters A and B, right, what's left for the length of these 2? So the length of Cn plus 1 has to be 2n plus 2. So the length of W plus the length of W dashed has to equal to 2n. Ooh, okay. So what could we have? And they're both even, right? So the point is this could have length 0, that could have length 2n. All right? So the number of ways I can do that is the number of words length 0 times the number of words length n. What if this is length 2, right, the next one up? Well, if that one's length 2, that one has to be length 2n minus 2. So that would be C1 options for that one, and Cn minus 1 options for that one. And you'll quickly see where I'm going for this. I could have C2 for this one, Cn minus 2 for that one. We're going to use a bit of sigma notation here, so we're going to add up k equals 0 to n, ck, so that one will have k options, that one will have n minus k options. Now, do I need to worry about overlap? No, and I will go all the way through, and at some point you'll get the same 2 numbers flipped, but that's fine, I don't mind that. Why not? Well, because at some point I could have that one being length 2n, and that one being length 0, right? So all the words that were there could be there. But these are different words. Why? Even if W and W dash are the same two words, just flipped the other way around, by virtue of that being an A and that being a B, it's a different word overall, so there's no double counting issues here. Take a second, pause the video, have a ponder on that one. So this is what we got. All right, so basically we're going to go through it. Now, we can double check this, right? All right, we can. Let's go over here. I'm going to check my working up here, because I've got a few of them, so I might as well check that my stuff works. Right, so the number of words at length 0 was 1. There is one word length 0. It is the word that is nothing. So based on that, C1 is C0 times C0, which is 1 times 1, which is 1, based on my formula. All right? So if I want C1, these two have to add up to 0, so they both have to be length 0. C2. Well, I could have a 1A, a 1 length word, B, a 0 length word. Or I could have A, a 0 length word, B, a 1 length word, which is 1 times 1, which is 2, which is what we got, right? 4 length words. Now, according to this, C3. So again, we drop it by 1 because of the A and the B. So the other two words overall up to 2. So I've got C2, C1, C2, C, come on, 0, plus C1, C1, plus C0. I won't lie, my C's and my brackets are getting very close together. C2. So that is 2 times 1, plus 1 times 1, plus 1 times 2, which is 5. And that confirms what we found just by trying to generate them. Pretty neat, right? It starts off really abstract, but actually there's a really satisfying way of generating these weird new words. This is interesting, you want to see more of it, drop us a comment. Did I miss anything? Anything you didn't quite get, let us know. In the meantime, subscribe, hit the bell so you don't miss any of these. Like, comment, the usual good stuff. I'm Nick, je suis Nick. This is some maths. See you next time.